Welcome. On the agenda for today, we're going to do notes on angle of elevation depression. There's practice embedded. By the end of class today, you should be able to apply knowledge of trig identities to real-life problems. So by definition, an angle of elevation is an angle created by a horizontal line of sight and the line above using the horizontal line of sight. So all that means is what you're doing is you have this horizontal line that is the ground, and then looking at your line of sight to the object. If you were to create another horizontal line, that angle of depression is this angle here that's formed by you and the object. An angle of depression now is, so we have the ground here, and that's a horizontal line. And from where the observer is, you can create another horizontal line, and then these two lines are going to be parallel, and then the angle of depression is that angle between this horizontal line created by the observer above to their line of sight to the object. That's our angle of depression. And again, it's important to note these two lines are parallel because that means that we can state that this angle here, the angle of depression, will then be equal to this angle here, the angle of elevation, because of alternate interior angles. So now you're skiing on a mountain with an altitude of 1,200 feet. The angle of depression is 21 degrees. Find the distance that you ski down the mountain to the nearest foot. So pictorially, we can show this. Here's the skier. Here's the angle of depression as they go down the mountain. And then this is the 1,200 feet. I'm just going to add to it that remember these lines are parallel even though it's not needed. We could also solve for this angle here based off of alternate interior angles and say that this angle here is 21 degrees. Again, we don't need it, but I just want to show that. So based off of this angle here being 21 degrees, that's my theta, I could label 1,200 feet as my opposite, and I'm solving for my hypotenuse. So remembering SOHCAHTOA, if I know opposite and I'm solving for hypotenuse, I want to be using sine for this problem. So the sine of 21 degrees is equal to 1,200 over x, multiplied both sides by x, divided by sine of 21, and then I got 3,349 feet. So then this one, we have an air traffic control at an airport, and then the angle of elevation is 34 degrees, which is here. The pilot reports that the plane's altitude is 3,200 feet. It's the nearest foot. What is the distance between the plane and the airport? So it's very important to make sure that you're marking things correctly. We're going from the plane to the airport. That means we're given the opposite from theta, and we're solving for the hypotenuse, because remember again, the right angle always points to the hypotenuse. So that means again from SOHCAHTOA we'd be using sine. So the sine of 34 degrees is equal to 3,200 over x, multiplied both sides by x, divided by sine of 34, and you get approximately 5723 feet. And then example 3, the figure shows a person parasailing. What is the parasailer's altitude to the nearest foot? So for this one, notice we want to find the height here. And in order to do that, again, keeping in mind these two lines are parallel to each other. So that means if I know this is 36 degrees, this angle here also has to be 36 degrees that I'm going to use as my theta. And from my theta, x is opposite. 400 feet is my hypotenuse because the right angle is pointing to it. And again, I would be using sine from SOHCAHTOA and solving for x, approximately 235 feet. Remember, always keeping in mind that when you're doing these problems for the altitude and the angle of depression, you just always want to make sure that you're also including whatever other missing angle is there based off of alternate interior angles, because it may be helpful in solving the problem. You don't always need to do that to solve it, but it's always good just to add that information just to see if you need it.